welcome Joel. I hope you're feeling better and we'll at least be able to come back part-time soon. We are looking at day 3-4 notes where we had an assignment. We had a new value, a new chi-squared test. Can you give me its name? It's not an easy word to remember. Morgan?
Homogeneity.
And homogeneity. So far we had goodness of fit and homogeneity. So this was practicing homogeneity. In some ways it's simpler than goodness of fit because you always pretty much just put it into your calculator. So to do that you have to use the matrix function and then find the stat test that relates to, it was called the chi-squared test on the list of stat tests. Yeah.
Like where are we? Like what day?
We're on day 3/4. It looks like
It
this.
has the wine and the music one.
It started with Y.
Oh wait, yeah, I got
But that's it. So we did this one for
Also,
our
I had this
homework.
homework from so very long.
Okay. Really? This quarter?
Maybe.
Maybe. Alright. Alright, so when you plugged it in, can you point to on your paper what your chi-squared and your P were on that one? Alright.
For which one?
The one you did it.
Your chi-squared and your P?
Oh, yeah. I did it on the calculator.
Yep.
I didn't.
Yeah, that's right. You have to catch up. With your chi-squared and your P. Okay, I didn't get that. Let's check how you find
We did
yours.
that yesterday.
I can find the table around it.
Okay. Alright, let me repeat at yours again. Alright, do you have your in there?
Paper more, and I should advance this.
Alright, what we'll do is we'll walk Ryan through this.
Oh, I see what I did.
What'd you do?
I took the total at the bottom and added it as another column.
Oh yeah, I
So you had
almost
the
did
wrong
that.
dimension?
Yeah, I
You
did a
had
4 by
4
2.
numbers in there. Okay.
Yeah.
Alright, so as you put yours back in, would you do that now? Would you speak out loud? And Ryan, I want you to do it as she says it. Do you have your calculator? Alright. Alright, so in order to do these tests, we pretty much, Ryan, we could do observed minus expected, quantity squared divided by expected, plus the same for the next. But by the time you finish, almost everyone has hit a wrong number somewhere and all that. So they just recommend we do it totally in our calculator. So this one, we're trying to put these numbers in. So Maddie, remind us how we do that.
Okay, so you go to second and then the x to the -1.
All right, Andrew, make sure he's finding those buttons.
Second.
That one.
And then you scroll over to edit. And then you like click enter so you're on the A matrix. Hold on.
Did you select matrix A?
Yes, I did.
All right, hit enter. Go ahead.
Then you, like you're at the top, so you put in a 3 by 2. You
Okay.
see it like the
Just
very top
Yeah,
row.
type it over it.
All right, and Ryan, it's, and everyone, it's always rows times columns. So if you put in a 2 by 3, you wouldn't get the right shape. Then you would know to go back and change it. So 3 rows, 2 columns. Now, can you enter these numbers, Ryan? Enter, just go to this spot. Is he doing it right?
Yep.
All right, he's putting these numbers in. Maddie, you're re-entering these numbers?
Yep.
All right, so then, what happens next?
Stat test.
Stat.
And then scroll all the way down to letter C, which is the chi-square test.
Okay.
And click enter. And then once it's under like observed, it should say matrix A.
Okay.
And expected, it should say B.
Okay.
And then you go down to calculate.
Okay, and then hit enter.
And what did you get, Ryan, for
You got
your chi-square?
3.2.
All right, and your P?
0.199.
All right, so everyone, Maddie, yours better?
Yep, got it.
All right, so now we're not done until we actually do the test. So we're going to take that p-value. Morgan, can you interpret what a p-value means?
Yeah. So, assuming that the null is
True.
true, then that's our p-value, and
That's the probability.
the probability that it will, that those,
would
that our
happen.
statistic
Yeah,
will be large or the same size or larger
yeah,
as
that's true, I forgot about that
the
sometimes.
observed.
Yeah, is that.
Is that?
Okay, all right, so would you take that then, and Bree, and you're gonna tell me now what to do with my null and my alternative hypothesis. Well, what will that lead me to do?
I don't know.
All right, what are you gonna compare it to?
Alpha.
All right, so alpha is
Okay, okay.
0.05.
I
I don't know
you
what to
got
do,
it.
so
Alright,
commit alpha.
It's
Is-
greater, so you're
so
gonna
the-
fail to reject.
Right, all right, you came
don't know what
rushing
to
in.
do.
I was
So
just-
this is not rare at all. This is our cutoff for rare. So this is pretty normal, so we're not gonna reject this. We're gonna fail to reject it. And when we do that, if we fail to reject it, we say there's not enough evidence to say that there is a difference. Or what were we trying to, what was our alternative? That there was,
Or higher than, is this the answer?
that the music played. The null hypothesis, oh yeah, this is different. This is this problem. No music played. This is the Democrats thing. All right, so I'm not so sure if you wrote in a hypothesis, so let's just do one from beginning to end, where you actually do the hypothesis, you do the rill, you do the test, and you conclude. So I've given you some skills, but not tied them all together. So let me give you one more to do that will give you practice in all of that. Haley?
So, I was a little bit blurry on the p-value. Would it be, is the observed 3.21, so assuming that the null hypothesis is true, 0.19 is the chance of getting 3.21 or higher? Is
As
that,
the chi-squared? I mean,
So-
that's chi-squared?
what's the, what, of getting what or higher? 0.19 is the
It's
chance.
higher, this or higher.
Oh, okay. I didn't say observed.
All right, let's do one from start to finish, and then that's all we're gonna do on homogeneity. Here we go.
Thank you, sorry.
So let's see if you can read it, we'll read it to our,
What's a what?
when everyone gets a paper, Dan, would you read the problem, please? Thank you. There we go.
A radio station trying to determine what kind of music to play takes a simple random sample.
All right, I see, I noticed
Insect
that.
citation. It's sample random sample.
Insect.
Of 50 students at each of the 3 locations, local, middle school, high school, and a college. The students are asked to choose which of 3 different music genres they most enjoy hearing on the radio. Here are the results.
All right, and the question, or the command?
Perform the appropriate statistical test to determine if there is any difference in the music preference of these 3 age groups.
Okay, so it doesn't tell us which test, so what is our key to deciding between goodness of fit and homogeneity? Could you walk us through that, Maggie? What was my main point on that?
Whether it was categorical.
Well, they're all categorical. So we're looking at music and middle schools, our middle school, high school, college. So that's all categorical. So goodness of fit or homogeneity.
So it's whether it's one way or two way.
All right, so is this a one-way chart or a two-way chart, Maggie?
Two way.
All right, so we're at homogeneity. Probably spelled wrong, but that's the test we're gonna do. All right, before we do it, we're gonna check the prereqs. So, what are the prereqs for this test? Shannon?
Real.
All right, real. So, I heard the word random. So, what does the I stand for, Shannon?
Independent.
All right, so since we do have a simple random sample, we've got to look at the number involved. So how many did they take from each school?
50 students.
So 50, so it's 50 times n, 10 I mean, and we're going to check that. Do you think the whole population of middle
All middle
schoolers
schoolers?
is less than 500? And high school and college.
You mean
So
more than
we're gonna-
500?
We're going to assume that we have a large
Yeah, she
group
meant
that we're
more.
working with. And then, what's the L? That's our new one, Shannon.
It is, I forget the word for it. It's,
It stands for
It's on the board.
large expected
Large
values.
expected
All right.
value. Yep.
All right, can we
So-
do that at this moment?
No.
All right, so we'll come back and check that out. So what do we do at this moment? Can you tell us, Kevin, what shall we do? What shall we do?
We have to, I'm sorry, I don't know.
I just say, we're gonna perform this test, so where do we go first?
We're doing
Just
it on a
like
calculator.
Yeah?
Okay, so you want to go to second matrix, or second x to the negative 1.
All right. And then,
You have to go to edit.
No, we can't check.
You can't do
that.
L yet.
Not until we get all the
all right,
your matrix.
Shouldn't we have
put in all your
decided on the
numbers.
HO
all
and
right,
HA?
so what size?
Oh, yeah. Miss Powell.
We should have decided on an HO and an HA.
Yeah, we
Okay,
forgot
we
to do our
started.
All right,
hypothesis.
and what is it?
That's right.
Click on.
3 by 3, you're right. I'm jumping ahead. All right, so go ahead, if you would, before you enter, or stop entering now, and let's come up with our null hypothesis. If you notice, they're almost always the same, except the scenario changes. Like before, when we were doing the actual one for the music, we said on the null hypothesis that there was no difference in the distributions of wines purchased in stores depending on the music played. So in this one, what's a good way to word this one? Can you give it a try? Ryan, I'll say there is no difference, and you get to continue.
There is no difference in the music
And the
preference
distribution,
in the distribution of the music preference of the 3 age groups.
right, music preferences among the 3 schools, or whatever, school levels, 3 school levels, something like that.
Big group.
All right, so H sub A, Ryan, then would be,
H sub A would be there is
Alright.
a difference.
all right, I'm not gonna rewrite it. There is a difference in the distribution of music preferences among the 3 school levels. All right, so some words are always going to be the same in your homogeneity test. There is no difference in the distribution of, we'll start, then whatever the scenario will be finished. H sub A, always there is a difference in the distribution of, and then you put in the scenario that we are covering. All right, now back to you, Kevin. We were putting in the data. You said it was a 3 by 3.
It was a 3 by 3.
All right, let's give everyone a dramatic pause while they put in the data.
Wait.
I've
I'm
done
writing
this
HA.
one.
I got it.
I don't know what I'm.
We can compare against each other if I have it. I did it.
What do
I did it.
I got for
Anyone got a
Yeah, I got it.
chi-square? Let me see if it matches
what am I
mine.
doing?
It does. All right, so you can write that on your paper.
I'll help.
I showed
That's
you
what
all.
I got. All right.
10.67 is
Yeah.
Chi.
Me too.
Is
Hi,
it
Bob.
three? Is it
All
3
right,
by 3?
everyone is
Yes.
coming up with a chi-squared of 10.67 and a p-value of 0.0305, something like that. All right, so
Anybody got a
let's
table
go
C?
back to real
I do.
and finish that. Shannon, can you guide us in the maze of our calculator to where we can find the expected values to check and see if we can even accept this test? So where are those found?
So you have to go back to
I'm gonna do one separate.
second and x minus
Go to
1,
stat,
and then click on the 2
tests.
for the B,
All right,
And go all the way down to C.
matrix B or 2.
and then enter, and then it gives you a table.
Then
All right,
Okay.
all right.
You get-
How are our numbers looking in the table?
They have to be greater than 5.
That's
how
not,
are
that's
they?
not
We're good to
right.
go. The
What's the
smallest
lowest
one is
one?
That's numbers
8.
from the old one, not from the new one.
Eight.
Okay. Well, yeah, you need to put in the right
Close.
numbers.
How do you get to this?
Whoa.
All right, anyone need help finding their expected values?
So you go to check your expected values, you go to second, and then you go to x minus 1, and then it gives you like the matrix, and instead of going over to edit, stay where you are and go down to the B and click the B,
The
and then
calculator has, if
just
you
click
told
enter
it to
again.
put it in B, it put it in B.
Yeah. What do you need help with?
Mine is in C, and because I went to make a new one, and I don't know how to change it
Here.
on the
Wait, I got it.
calculator.
We
Wanna
figured
show
it,
him?
yeah.
Show him.
Do I
Alright,
just
you
make
need
it
to
say
get
B?
to another matrix
Well,
because
it's-
you
you have to go-
started
it's not
in
involved
B and
here,
want
you
C.
go second.
You
X
have to
minus
go
one, and then you
to
hit.
second x to
Oh, okay,
minus
yeah.
1
There you go,
and
so
then
now it'll
hit
come up in your
C,
B.
and it'll take C.
You're still not getting the right Chi.
Yeah,
okay,
just
well
because A
you're.
is not correct.
Okay, hold on. You need to redo it. You need to edit, go to edit, and then do A. So then it'll let you change it. Is it 3 by 2?
Three
No,
by
it's 3 by 3. Yeah, 3 by 3. And then type in the things.
Okay.
There you go.
Alright, so I need someone to make a conclusion for us. Morgan, here is our p-value.
So that's less than alpha.
Alright, so p ended up to be less than alpha, and what happens when that
We are
occurs?
going to reject H sub O.
Wait, we're not going to the table C?
No, that's what this is.
No table C.
We're going to reject H sub O because there is not enough evidence to say that there's a difference.
Alright, so we went, because 0.03 is rare, 0.03 is below 0.05, therefore we'll say that probably wouldn't happen if H sub O is true, so therefore, again, Morgan, what do?
We reject H sub O because there's not enough evidence to say that there was a difference.
We're gonna reject H sub O and say, if we reject,
Oh, because there is enough evidence.
right, if we reject this, wait a minute, this was rare, right? So we're
Yeah.
rejecting this, saying that there is enough evidence
Yeah, there's
to
enough
say
evidence for a
that
difference.
there is a difference. Okay, gets confusing.
It's
All right.
gotten less confusing over the amount of times that we've done it.
Yeah, I agree with that as well. All right, one more test to learn about. So let's see. Any questions about homogeneity? You will recognize its use because you have lots of variables going in a two-way table. I guess
Yeah.
the smallest two-way table you would have would be a 2x1, but that might look like a one-way table.
If
So
you
I
have a
think you
2
need
by
2
1,
by
you
2.
can probably just not use
If I put in a 1 by 1, like a one-way table, will it still work?
I'm not sure. You'll have to experiment with that one.
No, 1 by 1 meaning. Oh
Like
yeah.
you're doing a test for the goodness of it. That's the one. That's the one. That new one.
All right.
Oh, blah, blah.
And your topics on day
You
3,
just
4.
entered one number.
On
Yeah.
your topics on day 3, 4. Do you see? Can someone pull that up? I got
It's probably
Maggie's.
5.
It says chi-squared test of association independence using
All
chi
right.
squared
So we
test
are
wisely.
doing the third test. So far we've had GOF, goodness of fit, homogeneity, and now we're going to have these are all chi-squared tests.
Andrew doesn't work.
And this one is going to be for
So domain.
association
You get
/
domain
independence.
No, you got the word for me.
So that's the one we're going to end with. And then we're at the end of the chapter.
Miss Powell, not again.
It's probably like test.
Yep, they just
My
keep
brain
rolling,
can't do
rolling,
that.
rolling.
I'd be serious.
Oh wait, we get a new.
It's not a new day, it's just a new problem.
So should I take notes on this one?
Yeah, just.
Daniel, picture.
Alright.
Kevin.
It says mine and you took it.
Have you seen that vine where it's totally
You
dark?
get the results now.
Yeah, that one.
Okay.
Daniel.
The cool thing about the chi-square test of independence / association, no matter which word you use first, is to do it exactly like the chi-square test for homogeneity. The only difference is the way you set up the H sub O and H sub A, and then you do it the same. So once we get over that, you'll be rolling down the hill of chi-square test for association. Alright, so we'll do this one and it'll train you to do any of the rest.
The smallest you can do is 2 by 2.
For what?
You can't do a 2 by 1.
Are you trying?
Yeah, no, so
Thank
it
you.
doesn't work.
Alright, Do angry people have more
What
heart
God said when
disease?
Noah said, "Can I take one of each?" That's
All
it.
right, so we need a
Yeah, we don't need
reader. I like
Right. See your red.
I like Bree reading.
Bree, would you read this for us?
Sure.
I know.
The angry people have more heart disease. Relationships between two categorical variables. A study followed a random sample of 8,474 people with normal blood pressure for about 4 years. All the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. This includes people who had heart attacks and those who needed medical treatment for heart disease. Here is a two-way table that summarizes the data.
So once again, you heard the word two-way table. So right away, you know it's not a goodness of fit. But how will you tell the difference between homogeneity and association? The way you will tell is the test for association has one sample group, one sample. If you recall, like the wine, they went into a store and played no music, then they went and took another sample in a store where they played Italian, went into a third store, so they had lots of samples going. In this last test for association, there's one sample group, and from that one sample, you're going to look at two characteristics. And you're going to ask yourself, is there an association between the two? Look at two characteristics, and you ask, is there an association? We're not going to get to causation, but at least we're going to say, is there association? Another way to say that is, are they independent of one another? So you'll see this test worded two different ways. I will show you both ways. I think this association is the most common way. So we have been comparing the distribution of categorical variables in several populations and treatments. This will be one sample, two characteristics. So if you notice when Bree read this, they grabbed a bunch of people and they're testing that group with two characteristics: heart disease or coronary heart disease, and anger scores. So did you see how it's one sample, two characteristics? That's the only way you know, is by reading the problem and see if it fits better in here or here, because they're both two-way tables. So.
Sad is going to try and get us with that little trick there.
Yeah. All right, so let's go ahead and say that real, because we're running out of time, we'll just say real.
The real deal.
Yeah, real is done. So we'll say real is done. And we'll check those off. Let's do H sub O. This is really the main difference between the two tests. And you've been trained how to do it for homogeneity. Now I'm going to say there is an association. I'm sorry, there is no, so remember, it's always a statement of no difference. There is no association.
Between the characteristics.
I wasn't, but
We actually list them between,
Okay.
what was it, coronary
Between
heart disease,
coronary heart
and
disease.
anger scores. And H sub O.
Hey, this is what I said you had yesterday.
And I'm not going to repeat it. You repeat
Remember
it on your
Wikipedia-
homeworks. There is
Dr.
an
Pedia.
association between coronary heart disease and anger scores. So you
this-
see how this H sub O is different from the one we did last night.
Yesterday, WebMD said Haley had that.
Last night we had the word distribution. Here we have the word association. Another way we can say this one, H sub O, is that CHD and anger scores are independent.
What?
That's
Oh, there's
another way
two
to
ways.
say it.
There's two ways to say it. If you're
Can't they be associated and still be independent though?
Well, this says there's no association.
I know, but that's what I'm asking. Like, can't they as long as there's no correlation, can't they still be associated with each other and be independent as long as they don't?
Not
It's
in
the
this
same
test. Not in this test.
Okay.
These are identical. No association is the same as saying they're independent. On
Okay.
pH of A, don't use the word dependent because it's kind of ambiguous. What
Not
do you mean, dependent on alcohol or what? So you want to say they're not
Reject
independent.
independency.
So CDH and anger scores.
Tendencies.
It could be. No, because dependency is a word,
Are
so
not.
independency could be a word, right?
Dependent.
That's not how, like,
It's
it
non-dependent.
works.
So don't say they're dependent, because
Independent.
that's unclear. So,
Independency.
all right. So to do this test,
I know
open
how
up
you
your
do it.
calculator
That's a word,
and
definitely.
enter these values as normal as you do for your homogeneity. So you're going to put in what size, Kevin? What size is this matrix?
3 by 2.
No, it should be 2 by 3.
Yeah, it's 2 by 3, my guy.
My calculator does it. It's like weird.
Kevin,
Whatever one I put in
Kevin?
first. What, Andrew?
Calculator didn't do that.
No, it
All
doesn't.
right, it
put
should
one
be a
in.
2-row
You
by
haven't
3
got it.
column, 2
No,
by
you.
3 to get the right number of spaces. Enter these numbers. If you had to find the degree of freedom, it was the same. 1 minus the rows times 1 minus the columns. So you'll have degree of freedom 2. You won't really need that. Your calculator should reinforce that though. So when you put those in,
Oh my goodness.
Got it.
and what kind of chi-squared are you getting?
I got 16.
I got that as well.
Oh, I missed
Yep.
that. You did the number.
What's the p-value is
P
probably
is
pretty low.
3.2.
High.
And no, it's 0.0003.
0.0003.
What? No.
That's why.
Oh, look, Bree, look, it's a scientific
Negative
notation.
4,
Keep looking at
which
it.
means you
Wait,
go
what
back
number?
down.
I didn't see
How
it.
did we get there?
Okay.
I also did.
Low, very, very, very low
How did we
p-value.
get that?
Yeah, I
Very
did.
good.
So therefore,
Once you put it in the
we
matrix,
are going to
what test do you go
reject
to?
H sub O.
It's the same as
There
where
is enough
homogeneity-
evidence
How many
to
zeros?
say there is
It's
an
like 4.
association between the two.
So
Got
wait,
it. Thank
so
you.
we reject it, right?
Right.
Okay.
It's very rare
Well, you can
that
do it
this
in
would
your
happen,
calculator
so
for
therefore we're going to
G.
reject this and say there is enough evidence
Yeah,
to
we
say
did.
there is an association.
So the only difference is the null hypothesis. And, okay.
Okay, so if you would then do the check your understanding for homework, it's one of these.
Your homework?
Check your understanding will be your homework. And actually finish before the bell. I'll have one more page to discuss after we go over that homework, and then we'll have to plan our tests.
Test
So
talk.
go! Alright, so
Miss
Pal, I
I'm
miss-
expecting to see you on
This is
Thursday.
There's a sneaky minus
Yeah, this
4.
isn't that bad.
Minus 4.
It's not that bad, but
Miss Powell, I miss lab.
So,
No, I just came across one of my physics labs, like on my Google Docs, and I was
Really?
like, that is the last thing I miss.
What? No, I like physics.
anyone have
No, I like
an idea now? If we finish Thursday and review, would you prefer tests Friday or Monday? Is very good.
Friday.
Wait, I gotta think about my
I
weekend for a
couldn't do
second.
that on Friday.
All right,
I
think
would
about
honestly
it.
prefer Monday.
Think about
Guys,
it.
we can study at our picnic.
Yeah, because then we